not actually using that information. Then it's okay.
I would say it wouldn't be able to do that. And then don't do it back, we try to do it.
As long as it's all fast.
Well,
I mean,
All right, guys, let's get started. Okay, so we basically have what, 2 weeks left, right, before presentation. So this today and then next Wednesday are the last lectures, right? And we're at the end basically. So at this point, we're just kind of almost where we're going to start reading papers, right? So we're going to like look at some ideas of some of the concepts that are available out there, and then I might just link. Okay, you want to know more about this? Go here. No more like that, right? So today I'm going to show you art style transfer, for instance. So art style transfer is a complex algorithm for you to, if you remember that scenario of taking an image and changing it to the style of Picasso, Monet, or something like that. So that's literally a paper. It's an algorithm. Obviously, it's built on neural networks and etc. But it's quite complex. Does that make sense? So that's where we are, and that's not even the hardest thing, right? So then there's the stable diffusion, Sora. Sora has no documentation probably, but I do have a nice tutorial for stable diffusion, so I'll provide that for you guys. But these are 100-page PDFs, right? So obviously I'm not expecting you to memorize it or anything like that, but read it. Right. So it's kind of where the culmination of the course, if that makes sense, right? With transfer learning. Bigger architectures, more data, more computational power. That's the formula. Okay. So what's important for me is that you guys do your last mini project, right? So that's due in 2 weeks. I've talked about that many times. I believe I wrote something, right? You have a little description of it. Yeah. So we can take a look at that again, just to make sure that's available. And then today we're just going to do some code examples of various things. So I think I want to say, yeah, mini project. Here it is. So you guys are not seeing it. So I'll remind you again, because this is the thing that I want you to focus on. So train a CGAN. You guys should know what this is now, because from scratch, we wrote both a GAN and a CGAN last week, correct? Do you guys remember? And I did, by the way, get it to work. I think towards the end, something was happening. So we can touch on that one again today. I'll repeat it, kind of summarize it basically. But it was working. Got it? So we'll start there. So this is, just like you did generative with text, now I want you to do generative with images. So I'm going to pick up with the CGAN, not explain the whole thing again, because I've already done that. But I'll go over, and then I'll introduce Fast AI. Also has GAN capabilities, right? Art style transfer, various things like that. So I'll provide basically many examples. So the instructions for the mini project: train a CGAN to generate color images. So that's one key difference, right? Why I did this with black and white images, right? The MNIST data set, whereas I want you guys to use color images. So you don't have to annotate the data set, but you do have to find it somewhere online. Okay, make sense? The condition can be classes or embedding. So, but that's what a conditional GAN was. So if you remember, we were giving it the one-hot encoded vector, basically. So, in the GAN, let's say I asked you on the exam, what's the difference between a GAN trained on MNIST and a CGAN trained on MNIST? So the difference is what? The GAN just generates random numbers, a 3, a 5, a 6. You don't know what it's going to generate. In the conditional GAN, You give it a 1-hot encoded 3, and it's going to generate 3s. You give it 1-hot encoded 5, it's going to generate a 5. Does that make sense? All right. So your mini project has to have that capability. Generate color images. I'm not saying you should do this, but apparently this data set is available. Pokemon, right? So, so you can generate Pokemon, right? And generate Pokemon that have particular class, maybe not the name, but like a power or something like that. And it, just generates those Pokemon that have that power. You see what I'm saying? So something like that's just an example. Whatever you want is entirely free, but definitely in color and conditional. Embeddings obviously could be more than classes. So an embedding could be an embedding of size 256 of some text. So you could actually write a sentence embedded, right, and then train it on that. It's a much harder problem, but you can definitely try it. You should leverage transfer learning via FastAI or the PyTorch hub. You can select topic of images and select your data set. Must be presented at end of semester, PyTorch only. Okay, no TensorFlow or anything like that. Whenever I see Keras, I get really angry. All right, because I know you just got it off the internet or something. All right, so yeah, please. So keep it in PyTorch. I almost want you to do it twice, but I'm going to leave it open-ended. I'm more interested actually in the CGAN where you pre-train the model. I care more about that, honestly. Obviously, if you leverage fast transfer learning, what you probably have learned is that it produces better things, right? So, but I almost make it pre-train and also with FastAI, but I'm kind of leaving it open for you guys to. Does that make sense? Yeah. So you can do it either way. Okay, so yeah, so that's the mini project. Are there any questions? This is due in 2 weeks. Okay. And I've already provided the CGAN code. Basically, you just got to make a tweak to make it color and it should work. Okay, and today I'll provide some kind of just really quickly examples of doing this with FastAI. I don't think that FastAI is great for doing this with CGANs, but it might be better now. So at your own risk, you choose to do a CGAN with FastAI. Okay, I will show you I wrote the PyTorch hub here, and I do plan to show you ResNets from PyTorch hub, and that's something that you can add and kind of give you an idea of how that would work, hopefully. Okay, with the CGAN. Any questions? No questions? All right, so let's get started. I'm sure I provided some links here. GAN link first, CGAN MNIST. So these are basically the two things I did last Thursday. I will pick up on the CGAN because I remember I wasn't able to show you the end result as we ran out of time. Then I have one thing we're going to do today is art style transfer. It's taking a while to load. Yeah, so we're gonna do this one, art style transfer. There's the link to the paper. Basically, at this point, you got to read those papers to really understand. But the idea is we're gonna do these scenarios. The images are on my GitHub, so you can just download them. So I really like the this one, Starry Night, and then making the university picture like Starry Night. Where is it? Yeah, there. So we're going to do something like that. If you have your own image, download your own image and take this opportunity to convert it into, style of your favorite artist. Okay, painter. All right, so we'll do this one. It is a type of obviously it's a generative model, right? Because that picture never existed before. The other two did, but not that one. And it's got the Starry Night vibe to it. All right, so we're gonna do that one. I just wanted to show you these links, and then I have a set of scripts, general application GAN, so you can click on that one, and it's basically these. So we'll do this GAN FastAI example 1, and then there's a few other ones. I haven't really spent too much time on these but I'm giving them to you. They work, and just, play with them. It's up to you how you end up doing the project. Make sense? All right. Any questions? All right. So let's go ahead and get started. So basically, all of this lives on the repo, right? So you go to the repo, go to transfer learning, and then this is where everything is. So it's going to be in either algorithms or fast AI. Okay. So, and that is because some of these are using transfer learning, are generative models, but are not necessarily using fast AI. So, like this algorithm here, for instance, has GANs, like art style transfer, conditional GANs, etc., but it just uses the PyTorch hub or something like that. Okay, so you can take a look at those. I guess I have some CNNs in here. Oh no, I just have some theory, but I covered this in 520. I remember, Lena, right? We did this before, so I'm not going to cover that. Transformers in there. Okay, and so basically, algorithms has like 1 or 2 scripts of note, and then under the Fast AI repo, we've done some of these, but if you go to GANs, you can see I have several generative GANs. Make sense? Yeah. So that's where everything is. Got it? So for your term project, you can find examples here in Fast AI, examples here in algorithms. And as far as the GAN and conditional GAN, I put those in here, deep learning algorithms. So if you go to 2nd edition, chapter 8, and you can see there is GAN first and MNIST-CGAN. Okay, and this is the one I completed last Wednesday. I just uploaded it. Okay. Got it? So all the code is available. Any questions about that? All right, perfect. So this hopefully is all you need to do your mini project. Get the data and then use those ideas to build your own solution. Okay. All right, great. So let's get started now with the lectures. So I'm gonna open up Scholar, GPU Scholar. And I'm gonna click on this one. All right. So I had some issues, as you know, my quota has been high. I ran these. If you guys have the same issue, you can try these commands. These are both Linux remove commands. I was able to clear some space, but just watch out. If you do something like that, you may need to reinstall some libraries. Okay, so do it at your own risk there. Anyway, so let's go ahead and start the GPU Scholar here. And we'll get a GPU. All right, so here we go. Yeah. So I'm gonna open up the apps, Jupyter Notebook. Okay. So I'm getting a GPU there. Okay, here we go. So we can start it. All right, so you can, I'm going to click on desktop. All right, so as I said, the thing I want to start with today is just the last script that we were covering on last week on Wednesday. Just to show that everything did work. I forget what the error was. We were having some kind of an issue, but it works perfectly fine. So So I'm just looking for. This is GAN's Fast AI. This one, right? Probably MNIST CGAN. Okay, so I'm going to click on that one. Right, and it should have the data stored in there. Yep. Yes, you can see they do look like threes. They do look like ones. You see that? So I'll run this. That came out a little bit worst. But basically, this is the exact code that we were doing last time. And I do think it's consistent with the way that we were coding it in class. I would say though, so the trick is here, right? So you give it, so I think, I don't know, we did the training. This would take a while. I don't want to rerun this again because it was taking like 20 minutes or so, maybe. Right. So, but here's the training. You can see the plot. Kind of let's pick up there, right? So your objective is that the trick goes down, that loss, right? So you want these losses to kind of meet together. Okay. And then I think basically, because it didn't finish training, you didn't see the inference part. So the inference part, basically, what do? We select the label that we want, 9. So here you create a torch tensor of zeros. And then for the ID 9, you provide a 1. So effectively, you do what? You one-hot encode the 9, right? The label, right? We need to do the unsqueeze at dimension 0 because it's expecting a 1 by 10, not just a 10, right? So it wants a batch of 1. And you can see the shape actually right there, 1 by 10. Make sense? Pretty easy. And then this is just a simple function to iterate to create a plot of 6 images, just to provide more intuition. So you can see the idea is you call the model, G model, and then you call the forward function, and then you provide to it the random G vector input and also the label tensor. What is this one here for the generator? If I asked you on the exam, what is that input to the network? What does a generator take as input? Noise. Very good. Exactly. So it took vectors of size 100, I believe, right? So it takes a vector of noise and we concatenate the vector of size 10, which has the class. So that's basically what we did. So just refer back to that video last week, right? But that's basically all you provide. So then this is a 9 when hot encoded, and then basically it generates output. Remember that we had spaghettified the image, so we have to reshape it to 28 by 28, and then there you go. So that's 9s, I would say. I would say this is a 9, this is a 9, this is a 9, 9-ish, 9-ish, right? But they look like 9s. Then you repeat the same exercise, 3s, right? So the same approach, and now that looks like a 3 to me, that looks like a 3, 3, 3. This is a 1. This one definitely is like the most accurate, right? 5 out of 6 are 1s probably, I would say. And then I did a 2, so 2 is harder, it seems. But I think if we gave it more training, might produce better results. Do you see that? Remember, we are pre-training this from scratch. So today, one of my goals is to introduce ResNet, right? And so maybe you guys can work out. So I'm not going to do this because this is part of your mini project, but I'm going to tell you where I think this should be placed. So either in your GAN or in your discriminator, right? So either one of the two classes, either the discriminator net or the generator. I think we were using MLP. I can't remember. But basically here, what could you do? You could do something like self dot ResNet. Do you see that? Oops, sorry, I misspelled that. Do you see what I'm saying, guys? So you could try something like this, right? Now it may make more, and then basically what you're doing is you're using the ResNet, a fine-tuned model in your class. Okay, to continue. Now it may make more sense actually to put this ResNet on the discriminator. So why? Because the discriminator takes in as input a vector. Oh, sorry, I'm looking at the generator. Sorry. This is the discriminator. It takes as input what? A vector of size 784. Do you guys see that? Does that make sense? So ResNets are for processing images, for instance, right? It's a CNN type of an architecture. So what do you need to change? Well, the input won't be spaghettified anymore. In fact, it'll be what? A grid, right? A matrix or a cube if it's RGB. But that's the project. So the project is to build the best CGAN you can. You know, you want to, if you're generating Pokemon images, right? And you say this or that characteristic, you want that image to be really good, right? So based on the conditional. So I'm just showing you like ideas of how you might be able to achieve that. By adding CNNs, that's another one, right? So instead of just normal feed-forward layers like we did here, you could add CNN layers. Or you can even go as far as adding a ResNet in there, which is a pre-trained model. So today I'll provide some code of ResNet, but I'm not going to integrate it into this. I'm just going to let you guys do that. Got it? All right. So let's go ahead and do that. So I think we looked at this script, right? We looked at the ones that it generated, the twos, which is not great. We've got the fours here, so I think this is a pretty good four. This is a four. So at least 50% of them, I would say, look like fours. Oh, I did fives as well. This looks like a five to me. That looks like a five. Yeah, I can see a five there. So about half of them. I also did sixes. So 6, 6, 6, 6, and so on. Oh, all right. So it keeps going. Sevens. That's a pretty good 7. I guess I did all the numbers. 8 is not so good at generating. Although this looks like a good 8. And that's it. Okay. Any questions about conditional GANs from scratch? All right, no questions. Okay, so I'm gonna close this one. And now we're gonna move on to explore just fast AI, right? So another set of approaches to create GANs and then art style transfer and so on. All right, so let's shut down that one. Okay, so now I'm gonna create a new script. I'm also gonna open up my shell. Okay, so I'm going to my quota. Okay. All right, so 22 gigs. All right, so I'm going to create a new script, Python 3.8. And I'm going to call it in class GAN, fast AI GANs. Okay, so that's basically, it's not even a CGAN. Okay, I'm not really going that far. Maybe if I have time next week. I'm really wrapping up next week, of course. So we'll see. So I'm going to change the name. And now I'm just going to show you, I have this in the transfer learning repo. So you can get the code from there. You need to go to Fast AI and then get GANs basically. Okay. Here I have 3 examples. I have this PET scans Fast AI. I have this image colorization GAN. So basically the idea with this one is if you have black and white images, you try to add color to them. That's a colorization GAN type of a thing. It works okay, not so great. But I'll show you. I'll kind of talk about them a little bit. Like I think there's this kid's picture in black and white, as you can see here, and it's basically going to try to colorize it. So the idea here is that it would learn how to take black and white images and make them in color. Which there is software that already does this on your phone, etc. Okay, so you get the idea. There's a PET scans Fast AI example as well. So some pets there. And you can see the input, the target, and the prediction. So that's, that's an image. The cat. Yeah, now these are not exactly producing them out of, we'd have to read about it, but I think it starts with the image and it does something. But we'll take a look at it if time permits. All right, so let's take a look at the first one. So I wrote this one, GAN Fast AI example 1. Okay, so this one basically is going to try to generate images of it's pictures of like rooms, different decor in a room, and it's going to try to learn how to do that. Doesn't work so well. I ran it for like 100 iterations, and it was getting better. It was getting better. So, but I think this is like the best example of GANs that you can try. Okay. So these are the pictures basically, as you can see, of like places, and it's gonna try to render. So you can see this is kind of what I got, which looks room. This looks like a room, right? This one here, like that's a window, and getting it to look better, it's the challenge basically. Okay, so let's go ahead and try that. Let's think of how this would work. So in class Fast AI. Okay, I'm gonna copy libraries. Okay, so, right. Okay, so it loaded. So basically we're using Fast AI Vision for a lot of this. Establish batch size. And size of the image. Okay. Just add a few functionality for plotting. So the data block is really with a lot of the work that you do really with Fast AI is usually to get that data block. So Fast AI has several data blocks. So for instance, an image block. Do you see that, guys? So basically it's saying like, what is the input and then the output here for this? So whenever you want to use Fast AI to solve a problem, you got to pay a lot of attention to this to see if you have one of these that already exists for your task. So I'll give you an example. Let's say that you wanted to give it images, but you wanted to produce regression values. Do you know what I mean by that? Like it would say 37, 55 for that image, right? That's the output. So then the block should be something like this for images, and then this would be a regression block, if that makes sense. Right? So it's got these predefined, pre-built objects that you can use. So in this case, we're going to use this image block. It's got this function, generate noise. It's got the familiar function, get images, a splitter, a resize, the transforms element. Because why do you need to resize? If it's using something like ResNet, ResNet will expect the images to be in a specific size, always, which is about 226 by 226. So you're gonna, if your images are really big, you're gonna lose resolution, but in general, it's gonna be like 226 by 226. Okay, and then the methods here are resize, and you provide the size basically, and also the cropping method. Does that make sense? All right. Normalize also with the predefined values. So you have your data block there. Okay. Then we're going to get the data. So here, feel free to try other things. But I'm going to try this L-Sun bedroom. So that's what the data set is called, bedrooms data set. Okay, so it's loaded. I had an issue with this, but I think it was, I had an error with it, but I ended up deleting the image and it worked. So I don't know if you guys are going to have the same issue. Let me know if you do get an error that it can't find an image, then you may just need to delete that image. All right, then you create the data loader. With D block over here. Okay, so take D block, make it into a data loader, provide the path for the images, for all the processing. This thing's, it's like the hard part, I think. Path and the batch size. Got it? All right, let's run that one. And then let's look at the images. So we're going to take a sample from the DLS data loader and try 24 images. Let's see if it complains. What's it doing? What is it? Okay. That's weird. Okay. All right, I'm gonna delete that. I may have mistyped something probably. All right. So I'm gonna grab it again. Here. And 24. Right. So there you go. So it just provided more images of the data set. So you guys already know how to grab your own data set from a folder, right, and load it into a DLS, correct? So that's kind of what you have to do again for this task. However, keep in mind this is only a GAN, not a CGAN. So that part you have to figure out. But that's what it's trying to generate. Apparently, it's got some movies in there, and then it's got rooms. Okay, so we're going to go ahead and down here. You have to create this object now, a generator and a critic. And these would be basically the generator and the discriminator, right? Just like we define the classes for the GAN, here you have the option. So with the generator, FastAI gives you a thing called basic generator. So how easy can that get, right? So the 64 was the size of the image, 3 channels because it's color, extra layers, 1, I guess, for the if it's got like a 4th layer. The critic, basic critic, a discriminator, again, the size is 64, number of channels is 3. And then it's got these leaky relus, I guess, as activation functions. But that is basically And I'm sure it's got more options, but that's your generator and discriminator, so that you can have a little bit more control of how you're going to set it up. And now we do the basic learner that FastAI uses quite a bit. So learn, and if you notice, in the past, what have we used? A CNN learner, right? Or a regular plain vanilla learner. In this case, you're using a GAN learner. What do you provide to the GAN learner? The DLS, which is the data set. And what else do you provide? The generator and the critic. Does this make sense, guys? Okay. And the optimization function in this case is RMS prop. You know, that's basically what it's using. Could be something else like Atom, etc. Got it? So let's click run. Okay, so that's loaded. Oh, one thing I didn't mention, notice over here, .wgan. So actually the learner can give you options. Maybe there is a .cgan. Right? So think about that. All right, so I hit run here. Now some metrics for the recorder. So recorder train metrics true, for validation metrics false, so you're not going to print those out as far as the metrics. Okay. All right. And here's the familiar learn fit. So I'm just going to run it once just to make sure it runs well, and then we can probably run it for a little bit longer and just go over the code again. So learn fit, so that's basically this guy here. 1, that is the learning rate. And this WD is probably some parameter that you can play with. Let's go ahead and run that. Okay, so it's going, this is where I was getting an error, but I fixed it by removing the image. So that ran pretty quickly, actually, no errors. That's good, I think. It says your generator is empty, but actually when I gave it more iterations, it was getting better. So I assume there's no, it's just a warning. All right, so if now we should have gotten a loss, I think. And there they are. Remember, now you get these, the critic loss, which is the discriminator, the generator loss, and so on. And these are not like the best. And then you can copy. And just basically learn show. Let's do, and this actually won't be very good. You see, actually, you can tell they're not very good, right? You guys see that? Kind of like just a random assessment. I don't think it's random. I think it's actually probably from the distribution, but this does get better with more iterations. Do you guys understand? Any questions? So this is basically a GAN with FastAI, a very simple, plain vanilla GAN with FastAI. Okay. It is using a WGAN here, right? So, you know, I'm sure it's a pre-trained model of some kind. All right, so let's give it more iterations. So I'm going to give it now 20. Let's make a mental map of what this looks like, right? And then we're going to compare after 20 epochs to see if it looks a little bit more. So here, for instance, they're all the same image. If you notice, it literally just it's giving you like the same image, right? So it's not a great generator. So I'm going to run it, and then while it's running, okay, so it's doing that. All right, that's running fairly quickly, right? You can see the epochs there. It's already up to 2 out of 20. So, all right, so let's recap. If you want to try again with FastAI for whatever reason, maybe you just need to generate random images of some distribution, like, you know, whatever it is. you invoke the libraries, FastAI in particular, and Vision from FastAI, size of the image, batch size. Here again, I will stress, like when I've worked with FastAI for some project or whatever, this is where I spend a lot of the time. In this data block, and in particular, I sometimes try to like, just so, okay, this is what you'll probably do. You're going to be like, I'm lazy sometimes, and I know like 3 of these things. And so I want it to fit my thing to one of those 3. Do you see what I'm saying? And that may not always be the best approach. Instead, it pays a lot to look at the documentation of FastAI to see all the options that they have. Because I can tell you that there's many. They've created one for just about anything that they can think of. Like they'll think of a new problem and immediately create a new one for that. Okay. So it makes a little bit more sense to look at those. Okay. But this is important. These block things that this is a transform block for images and then an output. You have here the generate noise function, get the images, and the resizing is really important. And the normalization is also very important. Now, actually, when you guys do your mini project, don't forget to normalize your data, right? And you know what I'm talking about there. This is the data set that you brought in. So just like we did before, you can use this automatically creates using the block, D block, right? Loads all the data. From path, it's an example of the images. And then the generator critic, you can basically create many architectures here. Okay, so this is just a very simple example. And then basically, yeah, so everything is put together with a GAN learner, WGAN, DLS, generator, critic, and the optimization. So yeah, that's it. So we finished this. The loss does not get so great, but it did finish. So I'm gonna hit save here. Yeah, so you can see they're better, right? Would you agree that they're better than before? At least they're different. Okay. So I did that with 20 and it ran fairly quickly. So I'm going to up that. This is one last attempt. I did it with 100 and I was happy, but 100 may have been too much just to get further improvements. So it does train fairly quickly. Any questions? The rest, I kind of, you have to play with this to improve results. Okay, so, all right, so I'm going to let it run for a little bit. I'm not hearing any questions on how to implement a GAN with FastAI. All right, so I'm going to move on to the next example, which is art style transfer. I just think that's pretty cool. To me, honestly, like I was able to do that myself for the first time like 2 years ago. But I had wanted to do that for years. For the longest time, I always had this idea. I'm going to take pictures of like my family and I'm going to make them into great works of art, like Monet's. And so I had this, and then eventually, I guess someone else had this idea, right? This thought, and they implemented the paper art style transfer. And then what I'm going to provide today is the PyTorch code for you guys to be able to do that if you feel like doing so. One key thing with that code is that you have to resize the image. So that's one thing, but as you can see, that image of Purdue is actually pretty big. So I think the resolution was not lost. Okay, so let's leave it training for a little bit. It's almost done actually. So we're gonna do that. You're gonna need to download the images that I provided, okay? And those are on the GitHub. I'll show you where they are. And basically you'll have to load them to your GPU to be able to do the process. So what's interesting about that model is that it actually, the algorithm is complex, but it really just needs like 2 pictures, right? It's got its whole algorithm, and it needs like the target picture, right? That has the style, and then the picture that you're trying to transform. And somehow, right, the algorithm is going to try to make this picture like this one over here. Okay, so that's what style transfer is. So you really just need the two images and the PyTorch code. Okay, so I won't go into a lot of the details of this, but I will show you the code at least and the paper, and you guys can go through it. All right, so I'm going to hit run for this one. This is the last example. What do you guys think? It's better, right? You're starting to see a room in there, maybe. I think so. I see like a window, a door or a window, and so on. And there you go. I think when I ran it for the most more examples, I guess I got something like that, which I think this is not actually much better than that, right? They look very similar. All right, great. So this will be one of the challenges that you will encounter with your mini project, is that the output will in fact look like this and not as you expected. All right, so let's go ahead now and end this Jupyter, because I think this one is complete. Pretty simple with Fast AI to do again. I'm going to close this. I'm going to go to running here, and I'm going to shut down also. So now we're going to start the in-class art style transfer. So I'm going to open Python 3.8. Okay. I'm going to rename this one in class. I think it's actually called Gaddy's. So Gaddy is the name of the author, the first author of the paper, because it's their implementation. There are other implementations of this technique, but this would be, I guess, Gaddy's art style transfer. Okay, so I'm going to rename it. All right, so this script is on the GitHub. You can get it from there. We can go to the repo, transfer learning. Okay, and this is not a fast AI algorithm, so then you should click on just algorithms. When you go over here, you can click on GANs, and there is the art style transfer example, basically. Okay, so that's it. So I'll talk a little bit about, there's another paper here. So if you're interested in there's this Torch Painter style transfer. You can read that paper. I'm not going to cover it in class or this semester at all, but you can take a look at that. And I think this should be the code for that if you want to play with it. But it's more something I try it at some point and I haven't touched in a long time. All right, so this is the script that we are going to be discussing and covering. You will need some images, so I provided those here. So this is the PNW original JPEG. So I'm using this, but you guys can choose your own image if you want to. I'm just using this example. And basically the idea is I want to convert these images to the style of various paintings. Not even the painter itself, but the painting, although you could maybe try the style of a painter, right? So that's also a possibility. You'd have to figure out how to do something like that. All right, so the images are, this is dancing. So this was used in the paper, I believe, a ballerina. And then basically you have some paintings, Monet, like the water lilies, which has a particular look. We've got another Monet, I guess, this one, which is more colorful. So it would grab that as well. We got Picasso, which, it's got that style. And Vincent van Gogh. Okay, it's Starry Night. So that one in particular is it's got its own characteristics, so it actually makes for a good example of art style transfer. All right, so for those of you interested, okay, so you need to download these images. So you can just, nowadays, you can just click on the image like that you want and click on this little button here, and it should download the image for you. Okay, once you've downloaded all those images, you will need to go to the Scholar here, right? Oh, here, actually. And then click on upload, select all the images, and then click upload. That's what I did. I didn't want to create. So you can see I already have them here. I have Van Gogh. Some of these Van Gogh resize are things. I ran this morning. So it'll generate these files for you. And I'll just overwrite them. And then I have this, the Picasso, the Monet 1 and 2, and the PNW 1 should be in here somewhere. There it is, PNW original, okay? So that's basically what we're gonna do. We're just gonna transfer the style, the art style, okay? So I already have the files in there, and then I have the code from my repo. So I'm gonna click on this, Gaddy's, I think it's with a T actually, Gaddy's. And the code is long. There's a lot of steps, basically. So Gaddy's neural style transfer. The neural style algorithm was developed by Leon A. Gaddis, Alexander Ecker, and Matthias Becht. Neural style or neural transfer allows you to take an image and reproduce it with a new artistic style. The algorithm takes 3 images, an input image, a content image, and a style image, and changes the input to resemble the content of the content image and the artistic style of the style image. Okay, so that's kind of the quick overview of how it works, right? If you're interested in understanding more, like if you want to read the paper, you can go ahead and click on that, and there is the paper. Should make for a nice reading of, this one. So it's a neural algorithm of artistic style. It was implemented around 2015. Okay. So, talks about fine art. So I'll just kind of like quickly go over it. But you can see there's the architecture basically, right, of what it's doing. And you can see it does use CNNs. As part of the process. And then basically, these are just some examples of what they did with, I guess this is Amsterdam or something, and maybe Germany. And it's, it transferred Starry Night to that city landscape, for instance. Okay, so you can see that. Some other examples there. It's got all the backgrounds, so you can go over that one. And it's got the references. I don't know that it's gonna, yeah, that's it. All right, so as I said, I'm not getting this deep into algorithms, so I leave this part just for you guys to figure out how it works, but we are going to run the code so that you can actually, if you choose to create some of these images. All right, so let's go ahead and get started. It's basically has a lot of functions. So I already installed all these libraries, but if you need to, you can install them. I'm gonna hit Control Copy. All right, so there's the libraries, Torch libraries, basically Torch Vision. That's in a nutshell what it's using. So let's hit run there. Okay, then we're gonna use Torch. The image size apparently is going to be 512, which is a good resolution, I would say. So if you're using CUDA, you can use bigger images because the GPU will be able to process. But if no GPU, like if you're running this on a CPU, you're going to have to use smaller images, basically. Right? So that our device is CUDA, of course, so we should be good. Okay. So then we're going to go over this, kind of analyze the code. All right, so it's got some transforms, basically. You're creating a function using transforms.compose. I think we covered this at some point earlier in the semester. Basically, what's it doing? It's resizing and changing to a tensor. All the images, right? The transforms converts to pill image, reconvert into pill image, basically. And then for mean and standard deviation for the normalization of the images. Okay. This to device is just adding it to the GPU. So basically this is, you're going to have content layers and style layers for the neural network, and you can decide the depth of it. But this architecture actually works really well, at least for my example. Okay. We have a image loader and an image shower. Okay, so here we're going to load the image. Okay, and some resizing. Image loader. And then to show. So a function for showing the images. Okay. Saving to pill image, basically. Or save as pill image, since you probably want to save these files to the file system. So that's one thing, so you can have them available to share with your friends. Okay. Then here you have the, you got to read the paper here, but this is basically the content. One of the objects that it uses, a content loss, basically. Okay, so the loss function, notice it is an MSC loss here. Okay. All right, and then the operations that it uses. So there's this gram matrix. Compute a gram product. So it's a special operation that it's performing, as you can see. Okay, so I'm sure that's described in the paper as well. The style loss, so it uses another loss function for the style transfer. And it's another MSC, if you notice. Okay. So hit run. Okay. Create a module to normalize input image so we can easily put it in a NN sequential. So that's what this is for. Okay, so it's just dividing by or subtracting the mean and dividing by the standard deviation. So normalization. Okay, get style model and losses. So this is putting everything together. We're going to copy that function. That's a long one. So this is the, big part of the architecture. Okay. Then let's take a look at, so get input optimizer, this, the optimizer parameters. Okay. Run the style transfer. So this is the loop, basically. Just to build a model. So there you go. Okay. So this will be the optimization loop, basically. So I'm going to click run. Download VGG pre-trained model. So this is an example now of downloading a pre-trained model which is a VGG model. So VGG is like a ResNet. It's one of those models, basically. So I will do another example of using ResNets in a little bit, but what this implies is that they're using ResNet to do some of the processing of the image and transform it. Okay, so that works. Hit save. All right, transfer image style. So now we're going to look at the image itself that we want to use. Okay, so I'm going to paste here. I'm going to remove this folder images because I didn't put the images in a folder. I just put them right next to this Jupyter. So you can remove it. But basically we have style image, which is a Picasso, and then we have the content image, which is the dancing ballerina. So I'm going to do that first. So basically we want the size. We need to import style and content images of the same size. So if you guys are going to do this, this is going to be pretty important that you get these shapes correctly. So we're going to look at them. And there you go. So this is a Picasso. And this is the ballerina. So we're going to basically try to make the ballerina more like Picasso. All right. So now let's go ahead and do this. Just another way of looking at the image. Okay. All right, so, and then there's various things you can do, but basically plotting the figure. This is a clone of it. And there it is. So ballerina. Run. All right, so this should bring everything together, okay? So this is the optimization itself. Oops, oh no. So we invoke the function run style transfer. We provide our CNN, which was a VGG, CNN normalization mean and standard deviation, the content image, the style image, and the input image, basically. And then now, which is, I think, just a matrix of the same size. And now we run it, and there it is. It's optimizing. So what does it use? It doesn't use a data set, right? Did you notice it wasn't using a data set? What it uses instead is a pre-trained model of EGG. Maybe if you change this to a ResNet, maybe it might provide better results. Something to play with. Okay. All right. So it finished. So hopefully now it works. So what we need to do now is just display, save the result and everything. So as you can see, it's not that much code. I'm going to remove this as I don't have outputs. I'm just going to overwrite. I'm calling the output ballerina Picasso. Plot it, show it, save it to file. So this is the code if you guys do this and want to save the file. And email it to yourself. Oh yeah. Sorry. I did that. Sorry about that. Hit run. And I think it transferred the style, especially to the background, although you can see it in her face, right? And throughout, it's like, right? Do you see that? So definitely in the carpeting or whatever this is in the background, you can see it's more like the Picasso squarey thing. Okay, so I think the next thing is just to make it bigger. Yeah, it's just open a little bit bigger. And there you go. What do you guys think? So that's basically the converted image. And you transfer the style of Picasso, basically. Any questions? And it's really just, as I said, a pre-trained model and then a specific algorithm for the art style transfer, but it's some kind of an optimization based on MSC functions, basically. So let's go ahead now and just do a couple more examples with this. So a Monet. Monet. Gonna remove this part. Monet. Okay, so that's gonna be our image. Notice that a lot of this is just resizing because I think the images that I got were not, were just paintings I found on the internet, right? So you gotta resize it. That's critical. All right, so print it, IMG1. And there you go. That's the Monet. That's possibly the one at the Art Institute. All right, so let's go ahead now. And so this is now bringing in that PNW image. I think one of the students in a class found this, and I just like the image. So that's PNW. This code just gives you the shapes because, as I said, key thing is you have to resize the images. So this one, it's IMG2. Right, and then there's the picture. That's the normal picture of the university. Now we're going to start to transfer the style of the different masters to it. All right, so I'm going to notice that I'm going to assign the images here. So to the appropriate size. So I'm gonna remove this images part here. All right, use the image loader, style, size, and everything. So you can see they are now the same size, which is an important feature, but they are color images. Okay. Run it. There they are, side by side, about the same size. And now we should be able to run. You need to create this third input image. So it's just a clone of the content one. So it starts, and the idea there is what? It doesn't start from scratch, right? Generating that image, that it starts from the actual original image and it starts to modify it basically. All right, so now we are going to run the optimization. Same ideas, this the VGG, standard mean, content image, style image, and input image. So again, content image is PNW, style image would be the Monet. The input image is just the same content image because when you're going to be modifying input image, so obviously you do not want to modify content image as that is your reference that you're trying to keep. Okay, so go ahead and run the optimization. So the loss is going down. That's a good sign. All right, and it finished. So now we should be ready to print our PNW as a Monet. And I know it looks a little bit small there, but we can make it a little bit bigger by doing this here. What do you guys think? Would you say it looks like a Monet? No. No. Let's look at the Monet over here. That's the Monet, right? That we're converting it to. Big one. Is that the bridge one? Yeah. And it's giving us, yeah, that basically. Mm-hmm. Yeah, I tried to make flowers, right? It actually, were those flowers there in the original image? Yeah, yeah, it does have. Well, I mean, yeah, it's so there certainly works better for grass than, let's say, for this object over here. Doesn't quite understand the difference. Got it? Make sense? Yeah. So that's kind of, I don't know. I like to show this because this was very impressive to me when I saw it. So I'll do one last night because I think Vincent van Gogh is really great. Or actually, you guys can see it. So there's the Vincent van Gogh. There's PNW. And basically repeat the same process. And that's what you get. Oh, this one's bigger. What do you guys think about that one? I think this is very much like a Vincent van Gogh because it's like Van Gogh would almost would layer the painting like a, you know, like three-dimensional in a way. So I kind of see that, especially there, I think. So anyway, that's what you can use with AI. Any questions? Any ideas of how else you could use this? Can you guys think of anything like another scenario where you could use something like this? Huh? Sell it online? Oh, fake images. Yeah, I guess I could take my own original image pictures and try to sell those pictures. But yeah, so that anyway, that's an example of what you can do with AI in 2015. So obviously about 10 years ago compared to what you can do today. All right. So that, yeah, so it's 6:16. Let's take a 10-minute break. I'm just kind of just showing you some last things. And then the next, we're going to come back and talk a little bit about VGGs and ResNet or AlexNet, sorry, and ResNet, and then do a ResNet from PyTorch. Just kind of play with that. Okay. All right. So let's take a 10-minute break. So I'll stop the recording here.